So an L structure is now switching the conversation to the semantics. The L structure is a choice of domain, and then on top of that a choice of which parts of the domain each symbol picks out in some way, right? I mean, some of the symbols will refer to sets of the subsets of the domain, and some will refer to subsets of the Cartesian product of the domain with itself, and so on. It's a little complicated, and so I am sweeping some things under the rug when I phrase it this way, that the symbols are going to pick out parts of the domain, and I'll sort of flesh out those details in a minute, but I want to say it somewhat simply to begin with. To give a little bit of illustration about what this means, if we take L to be a symbol in the language, right, a relation symbol, a two-place relation symbol, this has no meaning syntactically, right? We have not yet attached it to a semantics. But if we choose a domain to associate with this language, and then we also choose a subset of the pairs in the domain, right? So, talk about x's and y's, right? X anything out of the domain, y anything out of the domain, so then the pair xy is an element out of the Cartesian product of the domain with itself, right? A left coordinate coming out of the domain, a right coordinate also coming out of the domain. But if we associate this symbol with a collection of such pairs such that we put the pair in just in case the left coordinate loves the right, and here the left coordinate is talking about some person and the right coordinate also talking about a person, then this would be an L structure, or at least part of what we specify with an L structure. So this is kind of giving life to the dead symbols. We could give life to these dead symbols in a different way. We could pick a different domain, like say the integers, and then associate with LXY, anything we wanted to really, but let's just pick, for example, the integers with left coordinate less than 0, right coordinate greater than 2, and that's a different L structure on the same language. So now that was the intuitive phrasing. Let's go ahead and say what the rigorous phrasing of all of this is. An L structure is a specification of several different things. Now, I choose to put little subscripts L on each one of them to emphasize that each L structure, which I would call just this regular plain letter L, that's like some particular instance of an L structure. And every particular instance of an L structure will have a particular domain, a set FL, RL, CL. The ML, as I said, is the domain. It's it's just some set of objects, right? Particularly a set of objects that we choose to talk about. FL is a collection of functions, namely, for every dead symbol in the language, we associate with it a function. Now that function, the symbol has a certain number of arguments that it can take, and that's the number of products that we have to take with this, the domain on itself, so that we get an appropriately sized tuple that can then map, right? If it's a function on n arguments, then we need to give it an n tuple as its argument. That's what this is doing here. Similarly, RL is a set of relations associating the dead relation symbol with a meaning in the structure, namely a relation on the domain of appropriate length. And then we also get a collection of objects in the domain such that every symbol in the language is associated with an object. And we say that these functions, relations, and objects, or elements of the domain, are interpretations of the symbol.